So, good afternoon. My name's Alex Antrim. I'm a Senior Solutions Engineer for Ubico. And thank you all for coming to talk about Zero Trust and more specifically modern authentication across unified DoD networks. Can you hear me in the back, just to make sure? All right. So going back a little bit, we need to understand how we got here. So the administration released an executive order 14028 requiring a zero trust deployment plan, and agencies needed to submit that plan to implement a modern zero trust architecture for their networks. And this is also being looked at top tier levels of the DoD through a DoD ICAM working group and zero trust working group. Now, following the executive order, a national security memorandum, NSM 8, was released to guide agencies in implementing multi-factor authentication and encryption for national security systems. And this memorandum clearly identified verifier impersonation resistance for all users and administrators of software and software platforms. And just recently, an OMB memorandum M2209 talked about how agencies must use strong MFA, it must be enforced at the application layer, and it must be phishing resistant as a requirement for agency staff, contractors, and partners. Now, this zero trust maturity model has been implemented by by CISA, as well as in the Cloud Security Technical Reference Architecture. So as we look across the DoD landscape, we identify the three authentication protocols and authenticators that are primarily in use. Right there at the top, we have OTP tokens. They're approved as a non-PKI-based authenticator and are used in various systems and networks across the DoD, specifically in research and development, test and evaluation networks, RDT&E networks, air-gapped systems, air-gapped networks, and other legacy platforms that can't take advantage of more modern authentication. CAC-PIV, tried and true, 23 years strong. It's the most widely adopted single protocol authenticator, and it meets AAL3, and it's issued to service members and eligible government employees. And lastly, on the DoD CIO's approval memorandum, approved the YubiKey as a CAC alternative and multi-protocol authenticator. It's positioned as a strong bridge from taking CAC-PIV to more modern authentication like FIDO2. Now, it can take time to transition to newer technologies, so implementing a multi-protocol authenticator that supports current and future authentication protocols can positively impact that transition. As you see there, EAMS-A is a service that's provided by the U.S. Army. It's already supporting that strong non-phishable authentication protocol, leveraging on a YubiKey. So now that we understand those top three authentication protocols in play across the DoD, let's talk about how they meet AAL3. So OTP definitely meets AAL2 requirements and can be included as part of an AAL3 solution with other controls in place. And as I mentioned, OTP is mostly seen in air-gapped networks and other systems that have lowered the risk of stolen credentials, stolen OTP strings for a minimal phishing attack vector. CAC-PIV already meets AAL3 as a multi-factor authenticator. It's still only a single protocol though, so that smart card can still only support those credentials that are being issued to it and can't bridge over to more modern authentication protocols like FIDO2 that are above the line for phishing resistant technologies. And lastly, we have FIDO and FIDO2. It's currently being evaluated by the DoD in various use cases where DoD PKI credentials cannot be leveraged. We're eagerly awaiting the release of the NIST 863 TAC4, hopefully at the end of this calendar year. A draft should be here shortly. It's been a little delayed. But we're expecting to see FIDO included as part of an AAL3 solution. So we talked about the top authentication protocols. We talked about how they're meeting either AAL3 or AAL2. Now let's talk about how these multi-protocol authenticators are utilized in various use cases. So this multi-protocol authenticator that's supporting both CAC-PIV, or all three, CAC-PIV, OTP, and FIDO or FIDO2, it must have those secure cryptographic modules that are storing those resident credentials. Now those residential credentials are not shared between services or IDPs based on the consumption of those credentials. So for example, a FIDO2 credential that's been generated on the multi-protocol authenticator in that secure cryptographic module is not being shared to a CAC eligible or CAC enabled website, and vice versa. So this is important when you're looking at services and websites within your ecosystems that can't leverage DoD PKI, and also supporting, say, non-CAC eligible users like mission partners, foreign nationals, dependents, and veterans. What are they going to be using to authenticate into these ecosystems and into these environments to get similar, if not the same data? One kind of story I wanted to talk about is how a multi-protocol authenticator can span the complete life cycle of a service member. A young person, a teenager, can enter a recruiting depot. They're talking to the recruiter, getting ready to enlist in that military branch. They might be issued a multi-protocol authenticator with FIDO2 credentials so that they can access some of that branch's specific websites. It's not CAC enabled, they have not been issued an identity by DMDC, however they are empowered now as part of the enlistment process to access some crucial data to help them in the transition. They take that same multi-protocol authenticator with them to basic training. They are now issued DoD credentials onto the cryptographic modules of that authenticator. And now they're using that to authenticate into both CAC-enabled websites as well as modern websites that are implementing FIDO2. And that could be the span of their entire tour of duty. They take that same multi-factor authenticator with them as they retire and are now using it to access services like Veteran Affairs and the IRS, continuing that transition all the way through from pre-enlistment through their enlistment cycle and into retirement, all keeping the MFA requirements in place. So one primary use case that was being developed across DoD branches and agencies is supporting telework, supporting mobility. So let's take a look at how PKI and mobile would require proper integration. So an end user right now wanting to use CAC would require an external reader. That can present typical challenges that you see, the dongles, the form factor changes as mobile phones change from Type C to Type A, from micro USB to Type C to Lightning. Can your external reader follow that and be supported by the adapters? It also requires third-party tools. Modern mobile phone platforms are not able to support natively smart card authentication on iOS and Android, so you need third-party tools that have some type of PIV middleware that is able to read the credentials either on a CAC and a reader or on a multi-factor authenticator with the properly provisioned credentials. Soft credentials limit the device usage. They're being presented directly into the secure element of a phone, but that can only be done on a GFE phone. We have confirmation that DoD issued credentials will never be, soft credentials will never be loaded onto a personally owned mobile device. So when that phone dies, it falls in the drink, it gets wet, you have now lost all mobility capabilities for that end user. And policies right now supporting BYOD are still in development. There's still a lot of work to understand how the data in transit, how the data in rest, and how these new zero trust architectures are being supported by personally owned and government owned mobile devices. So some of the resolutions. Well, you can remove the soft credentials off of the government phones and put them on a approved multi-factor authenticator. So now you have a portable root of trust. You're able to move this authenticator from GFE device to personally owned mobile device and personally owned laptops. So now you have a wide range of use cases for the end user. We have different capabilities in multi-factor authenticators that aren't present in current CAC. We don't have the capability of NFC. We don't have the capability to directly communicate over the USB channel. And so multi-factor authenticators out there today that are approved by the DoD have these capabilities. And as these authenticators are being evaluated and these more modern authentication protocols being evaluated and approved, they can be in turn folded into cleaner policy updates. We want to make sure that the mobility and telework policies are in place to support proper MFA and authentication into the resources that they need to support the mission. So what's working today? Well, first we'll talk about what's working for PKI. And we talked about the challenges and the resolutions, but right now PKI does work for a mobility policy or a mobility strategy. Right now, there is a service, a derived credentialing service from DISA that derives credentials from that DMDC identity called Purebred, and it derives credentials directly either onto a GFE-owned mobile device or onto an approved multi-factor authenticator. So the hardware token plus a derived credential gives the end users the ability to authenticate into a device-agnostic model, meaning it can be used to authenticate into GFE workstations, GFE mobile devices, personally owned workstations, and personally owned mobile devices. So you can see how that portable root of trust with properly provisioned DoD credentials is working today to access CAC-enabled websites. Well, what's working today for Fido? So this one's a little bit challenging right now because there is no unapproval or approval for Fido 2 right now for the DoD. And now a successful pilot just took place recently with the New York Air National Guard. The New York Air National Guard had a very unique mission set where they needed to authenticate into CAC-enabled websites as part of the mission, as well as meeting MFA requirements for their local government disaster and emergency services. And so what did they do? They took a YubiKey and they were able to provision the DoD credentials onto it, and they were able to work through the identity proofing capabilities of login.gov to now be enrolled as a Fido 2 credential for those local state-owned disaster and emergency services. And this led to wide adoption by the service members when they realized that they could use the same authenticator to access both ecosystems. Right now, YubiKeys can be registered with EAMS-A to give secure access to both CAC-eligible and CAC-enabled sites, as well as non-CAC-eligible. So dependents are able to go in with a username and password and enroll a YubiKey as their universal second factor token to access sites that were previously not available to them. So that really broadens the user population for the services that are behind EAMS-A. And lastly, Fido 2 is also being deployed right now for privileged users in Azure tenants across the DoD. Privileged users aren't able to leverage their DoD PKI end user credentials for those privileged accounts, but they still must meet the MFA requirement. So what do? Well, Azure supports Fido 2. So by going through the initial Microsoft identity proofing, you're able to enroll a multi-factor authenticator as their Fido 2 token and effectively meeting MFA for all of those privileged users that are administering the Azure tenants. So we talked about the two authentication protocols, but these are two very unique ecosystems. Right now on the DoD PKI side, we see CAC-eligible or CAC-enabled websites that are supporting email, like OWA in the past, and now Outlook or 365 tenants. We're seeing websites like Deers. We're seeing financial services like MyPay, as well as some document sharing and other productivity suites. That's all within the DoD PKI ecosystem. On the other side, we have Fido. Fido is now more commonly used at those local government supports. For veteran services, we have Fido 2 token support for VA. We have disaster support databases as well as medical services, not to mention the social media and other personally available services and resources. But these are two totally unique ecosystems, and right now, we're working with all of the IDPs, and the DoD is also working with various IDPs, but they're right now consuming those credentials separately. So a zero trust architecture is being developed to support, as it's being developed to support the modernization of DoD networks, it requires that strong identity provider. It's important to bring those two ecosystems together, regardless of what authentication protocol is being leveraged and consumed. And a strong identity provider can manage both of these authentication credentials, or a third one if they're still using OTP, and effectively map them to that single DMDC object or identity. And so it's really supporting a wide range of authentication protocols to all of the required services and resources, bridging from DoD PKI over into FIDO. And that IDP, it needs to support the enrollment of a multi-factor, multi-protocol external authenticator, right? That really supports a device agnostic model. So now, instead of being limited to only smart card authentication or a single protocol, you are now able to authenticate into a device agnostic model, all mobile devices that have the proper connectors, as well as workstations on both GFE and CFE. But that external authenticator needs to have the proper cryptographic modules to store those credentials and ensure that they can't be extracted, and that the non-volatile memory and volatile memory is set properly to ensure the security of those credentials throughout the life cycle of that authenticator. These multi-factor authenticators can also support non-CAC eligible. We talked about some government employees that are not CAC eligible, dependents, and of course veterans at the end of that tour of duty when they retire. And one thing I wanted to highlight when we talked about the New York Air National Guard pilot use case is the lessons learned, right? It's one thing to talk about the successes of a pilot. It's also what did we learn, and what can the DoD use as they're continuing to evaluate these more modern authentication protocols and these IDPs as part of their ICAM modernization efforts. So as I mentioned before, adoption increased when the service members understood that they were able to use a single authenticator for both DoD PKI as well as those local services leveraging the FIDO2 authentication protocol. They realized that they didn't have to have a bunch of authenticators or a bunch of cards in their wallet or authenticators around their neck. The ID proofing that was made available from the FIDO2 services, the CAC-enabled capability to properly identity proof the end users, leading to quick delivery and ordering of the security keys, also improved that experience. One reason for the success of this pilot was that there were internal champions throughout the Air National Guard wings that were originally deploying it. We had champions within the NIST, the NIST thought leadership, as well as the Air National Guard leadership and Air Force Reserve Center leadership. And those internal champions were vital to the success of the pilot. Now, one luxury the Air National Guard had was that they were able to identify a web service that already had FIDO2 as a capability. And that we're seeing more and more of that made available to the DoD pilots now, especially with Azure, as I mentioned earlier. Since the Microsoft ecosystem already supports FIDO2 tokens, there is a clear transition from DoD PKI to FIDO2 if you're sticking within that Microsoft ecosystem. But of course, with all of the successes and all of the high points, there was a little bit of a low point. So the compatibility challenges in these maturing infrastructures. So as the DoD ICAM Tiger teams at the top tier of the DoD PKI office are working towards developing the requirements of the ICAM stacks, the DoD branches are still looking to deploy their own ICAM. And so those requirements are crucial in developing the proper identity providers to be able to consume, manage, and effectively issue those credentials, as we saw in that earlier graphic, bringing the two ecosystems together. So as those requirements are being developed by the DoD ICAM team, we're hoping that they filter down to the ICAM modernization efforts for each branch, so that you can have proper federation of these credentials, and they can all be seen and consumed to give the information cleanly to the warfighter. And I think I'm coming up to the end, but we just wanted to talk about what we're seeing today. We're seeing security keys with derived credentials. We are on the DoD approved CIO memo, leveraging the DISA purebred credentials. We're also seeing FIDO-enabled websites like EAMS-A, login.gov, and as I mentioned, Azure and the Microsoft environment. So we're really hoping to see secure hardware authenticators right now as we bridge from DoD PKI over into modern authentication. That was very, very quick. Just the last few words on some of the agencies, organizations that we're working with across the DoD and FedCiv. I'm happy to take any questions, and you can always come by our booth and we can go into a deeper technical dive. Any questions? None. I'll stick around at the end if you want to come up to me one-on-one. Thank you very much.